Last week, I had one of those moments, the kind that resets your nervous system. A student turned in something that looked flawless. Perfect vocabulary, clean formatting, even the tone sounded older than them. And I'm not saying that to accuse anyone, I'm saying it because this is the world we're teaching in now. So I did what I think we're all learning to do. I asked one follow-up question in person. Not a gotcha, just walk me through why you chose that step. And they froze. Then 2 minutes later, when we pulled out a similar problem, they tried it again with a little coaching and they started getting it. That was the reminder I needed. The tools changed, but the learning didn't. The same things still work. Hey, I'm Peter Weise. I've been teaching for 23 years, 18 of those in Kentwood. I teach high school science, chemistry, physics, and a science of cooking class. But this podcast is for all secondary disciplines. Today is episode 1, What Stays the Same? Today is episode 1, What Stays the Same? If AI has you wondering what still works, I want to give you a simple reset and a few low-prep routines you can use this week to keep learning real without turning your classroom into a policing system. Here's the big idea. In an AI-saturated world, the learning engine is the same. Students still learn by attempting, practicing, and getting feedback. Their working memory is still limited, so overload still looks like shutdown, and trust matters because students try more when it's safe to be imperfect. AI can produce a product, it cannot install understanding into a student's head. So if you're feeling like, okay, now what? My answer is not new policy, it's not a new tool, it's designing class so the learning work happens in front of you in small, repeatable ways. Because the biggest risk right now isn't just copying, it's skipping the sense-making. It's outsourcing the part where the student actually forms the understanding. Today I'm going to give you 3 routines that work well in any class, and I'll show you what they look like in science and ELA with quick bridges to math and social studies. A very quick research anchor, just enough to support what we're going to be talking about. First, research suggests students remember more when they practice pulling ideas out of their own brain, even if it's imperfect compared to just reading or rewatching. This is called retrieval practice, but really it just means make them try from memory. Second, when a skill is brand new, it helps to show a short example first so students aren't overwhelmed. Then you fade the support and they do more on their own. And third, feedback is most useful when it's clear what the goal is, where the student is right now and what the next step is. Not 10 comments, one usable next step. Sources are in the description if you want, but the point is simple. The routines are built to protect attempt, practice, and feedback. Routine number 1 is the smallest one, the 3-minute try first. The problem it solves is instant outsourcing. The moment a task feels hard, the brain looks for an escape hatch, a friend, a tab, a search result, a chatbot. Adults do it too. So the move is not ban everything. The move is normalize the first attempt. It's the 3-minute try first. And I want to name something explicitly. In an AI-saturated world, the physical artifact matters. It's on paper or a whiteboard. A pencil moving is the simplest proof of work, not as a gotcha, just as a normal part of learning. Here's how it's going to sound. If you put one prompt or problem in front of them, you say, all right, 3 minutes, pencils moving, no devices, no talking. Your job is not to finish. Your job is to start. Messy is fine. Wrong is fine. Attempt is the goal. If you get stuck, circle where it broke and write one question. That's the win. Then you set a timer for 3 minutes. On paper or a whiteboard, the physical artifact matters. What students do is simple. They attempt. They circle where they got stuck, then they write one question. What you're listening for, evidence of learning, is not correctness yet. It's whether they can name what they tried. Can they point out the step that broke instead of just saying, I don't get it? Then, after 3 minutes, you release help in a structured way, and that structured part matters. You might say, now you can ask for a hint, not a solution, a hint. Or you can check a worked example, but you still have to do the next problem yourself. If you allow tech help after the first try, you can. The key has to be coaching, not delegating. If a student uses an AI tool, I want it to be, help me figure out my next step, not do it for me. A tool-agnostic alternative is simple. You can just give a short work example on the board and send them back to the next attempt. If this goes sideways, here's the troubleshooting line. If the student freezes or refuses, lower the stakes. It's not the expectation. You say, you're not being graded on being right now. You're being graded on attempting. I need to see your thinking so I can help. And if they still won't start, shrink the first action. Write what the question is asking, or draw a picture, or list what you know. Start anywhere. This is routine 1. Routine number 2 is the one that saves your sanity. I call it attempt evidence, and it's 2 tries plus where it broke. The problem it solves is the perfect looking final product with no trail of thinking. It also solves the teacher burnout problem with the trying to be a detective. Instead of asking, did you use AI? You ask, show me your learning work. Here's how it runs. You tell students, this assignment has 2 attempts. Try 1 as their first attempt. Messy is allowed. Incomplete is allowed. Wrong is allowed. Then they get 1 input. That input might be you. It might be a peer check. It might be a worked example. It might be a hint station. It might be an AI coach if you allow it. Then do try 2. And the key, the part that makes this work, is the 1 sentence at the end. It broke when, or the key change I made was. And here's why I like to say out loud. I'm grading learning work, not final polish. 2 tries, 1 sentence about what changed. If you can explain your decision point, we can work with that. What students do is produce 2 attempts and label the decision point. What you're looking for is whether the explanation gets more specific over time, not, I didn't get it, but I messed up the ratio here. I forgot to balance the forces before solving, or my evidence didn't actually support my claim. If you want to allow AI between tries, keep it simple and transparent. 1 sentence requirement. AI suggested blank, and I verified it by blank. That's it. No long reflection. You're teaching verification and ownership. Tool agnostic alternative is easy. If you don't want any AI involved, the input between tries can be a worked example, an anchor chart, a peer check with a checklist, or a 1-minute teacher conference. If this goes sideways, here's the troubleshooting line. If a student turns in try 1 blank, you calmly say, try 1 has to show an attempt. Even if it's a diagram, a sentence, you can't skip try 1. And if students rush try 1 just to get to try 2, pair it with the 3-minute try first. Make the first attempt real. Let me give you a classroom example because I think this is where it's going to click. This is the one I see a lot in science, but it's not just science. Chemistry, limiting reactant, multi-step problems. A handful of students submit solutions that are flawless, don't know what to write first. They don't know which ratio to use. They don't know what limiting means in any action. In that moment, I don't accuse. I don't do the courtroom thing. I treat it as data. I say, good, this tells me what I need. Then I put up 1 short work example, not the whole unit, 1 clean setup, and I narrate 1 decision point like, I'm choosing this ratio because it connects the thing I have to the thing I want. Then students do try 2 on a new problem. 2 minutes with a partner, then independently. And then when they submit, they circle the steps that changed and write 1 sentence, it broke when, or the key change was. This change is not just accuracy, it's that students start being able to explain that decision point. That's learning, and you don't have to prove anything. You design the learning work to happen in front of you. Routine number 3 is about feedback, because feedback only matters if students use it. This is the tiny feedback loop. The problem it solves is the feedback black hole. You comment, you mark, you explain, you spend time, and then nothing changes. So here's the move. Pick 1 successful criterion for this week. Just 1, not 10. Maybe it's your claim must answer the question, or your diagram must show all forces, or your evidence has to be tied to your reasoning, something you can see quickly. Then for a short cycle, 2-3 days, you give feedback only on that 1 thing. So here's what it sounds like. I'm only looking at 1 thing today so you can actually use the feedback. This week's focus is this 1 skill. If you fix this, your work improves everywhere. Tomorrow's warm-up is yesterday's fix. What students do is apply feedback immediately. The next day, class starts with a 60-second fix-it task. They correct 1 thing from yesterday based on the feedback. Evidence of learning is simple. Do you see fewer repeated areas on that criterion? Do students start catching it themselves before you comment? If this goes sideways, here's the troubleshooting line. If a student says, why are you only grading 1 thing? You answer, because I want you to improve 1 thing on purpose. When we try to fix everything at once, nothing sticks. And if you're worried you're missing other issues, remember, this is a short cycle. Next week, you can pick a different target. Now, I want to make sure this feels usable outside of science. Here's what an ELA example might look like. Imagine 10th grade ELA. Students are writing an argument paragraph. Claim, evidence, reasoning. A colleague might start with a 3-minute try first. Write your claim, then choose one piece of evidence from the text. No devices, just you and the text. Then students do try 2 after a quick checklist or a peer conference, and the student adds one sentence, "The key change I made was." Usually, it's about tightening the claim and choosing evidence that actually fits. The evidence the teacher is listening for is not just a polished writing, it's that the student can point to where the evidence came from and explain how it supports the claim. The evidence the teacher is listening for is not just polished writing, it's that the student can point to where that evidence came from and explain how it supports the claim. Now a couple quick bridges. In math, this can be as simple as, in 3 minutes, show me your setup and your strategy choice. Even if they don't finish, then the second try is the corrected path with the "it broke when I," so you can see the misconception. And in social studies, the same routine works for sourcing and reasoning. Try first is a quick, who wrote this? Why? And what claim does it support? Then the revision happens after a sourcing checklist with one sentence about what changed. Same learning engine, different content. 2 quick pitfalls because this is where people get exhausted. First, over-scaffolding. When AI shows up, it's tempting to lock everything down or scaffold everything so much that students never actually practice. A phrase that helps me is, support the try, don't replace the try. Second, courtroom culture. If your main move is accusations, students will hide or disengage. If your main move is routine, students will participate. A line I like is, "I'm not trying to catch you, I'm trying to see your thinking so I can help." And one quick privacy note. If you use any tool with students, keep student identifiers out of random platforms. Use what's approved for your context or keep it tool-free. Today's routine works either way. All right, try it this week. Pick one assignment, one task, one lab conclusion, one problem set, one paragraph, anything, and add attempt evidence. Tell students, you're turning in try 1 and try 2. Try 1 can be messy. Try 2 is your improved version, and you must add one line, "It broke when," or "The key change was." Then pair it with a 2-minute retrieval exit on the same skill. No notes, one question, just a quick pull-up from memory attempt. Prep time is about 10 minutes. You're basically changing the directions. What success looks like is not perfection. Success looks like help requests that get more specific. Success looks like students pointing to decision points. Success looks like fewer perfect but empty products. So that's episode 1, What Stays the Same. Practice still matters, feedback still matters, cognitive overload is still real. Trust still changes what students are willing to do. AI changes the environment, but it doesn't rewrite how brains learn. Next episode, we'll talk about what actually changes and how to respond without burning yourself out. If you try one of these routines this week, I'd generally like to hear what happened, what worked, what flopped, what questions it raised. Drop a comment or send me an email. And if you got a real classroom scenario you want me to unpack, send it. Here's what my students are doing. What should I do next? That's what this podcast is for. Thanks for listening. I'll catch you in the next one.